Hello everybody, my name is Daniel Jin, and today we will be going through the problems of the AMC 10B from the year 2012. So let's get started. First problem, each third grade classroom at Pearl Creek Elementary has 18 students and 2 rabbits. How many more students than rabbits are there in all 4 of the third grade classrooms? So there's 4 classrooms and we have 18 students minus 2 rabbits equals 4 times 16 equals 64. So the answer is C. Second problem, a circle of radius 5 is inscribed in a rectangle as shown. The ratio of the length to the width of the rectangle is 2 to 1. What is the area of the rectangle? So if the radius is 5, that means this is also 5 and this is also 5. So this would be 10. And since the length to the width is 2 to 1, this much would be 2, and this much would be 20, right? And so the answer would be 20 times 10, which is 200. The answer is E. Number 3, the point in the xy plane with coordinates 1000, 2012 is reflected across the line y equals 2000. What are the coordinates of the reflected point? So we have the xy plane, and then let's just say this is 1000 and this is 2012, right? And so let's just try to draw a line y equals 2000 over here, like this. Y equals 2000, and that means the length from here to here would be 12, and for the point, which would be right here, this would be the point 1000, 2012. For this point to be reflected across this line, then it must go 12 downwards too, right? So the y value would be 2000 minus 12, which is 1988, and so it's 1000, 1988. The answer is B. Number 4, when Ringo places his marbles into bags with 6 marbles per bag, he has 4 marbles left over. When Paul does the same with his marbles, he has 3 marbles left over. Ringo and Paul pull their marbles and place them into as many bags as possible with 6 marbles per bag. How many marbles will be left over? Okay, so let's say that Ringo and Paul, they have already placed their marbles into each bag, right? So Ringo has 6 marbles per bag, so he has like 8 bags with 4 left over. Paul has B bags with 3 left over, and if we add these up, we will have A plus B bags plus 7, which is 1 bag plus 1, so we will have 1 left over. The answer is A. Number 5, Anna enjoys dinner at a restaurant in Washington, D.C. where the sales tax on meals is 10%. She leaves a 15% tip on the price of her meal before the sales tax is added, and the tax is calculated on the pre-tip amount. She spends a total of $27.5 for dinner. What is the cost of her dinner without tax or tip in dollars? Okay, so let's say that the cost of her dinner without tax or tip, let's say that this is X, right? And she had 10% sales tax, which means 0.1x, and she left a 15% tip, which means 0.15x, right? So x and 0.1x and 0.15x, all of them added together is 1.25x, which equals $27.50. So this is 27.50. So x equals 2750 over 125, which is, if we divide by 25, then that will give us 110 over 5. So this is 22. So the answer is D. Number 6, in order to estimate the value of x minus y, where x and y are real numbers with x is greater than y is greater than 0, Xiao Li rounded x up by a small amount, rounded y down by the same amount, and subtracted her rounded values. Which of the following statements is necessarily correct? A, her estimate is larger than x minus y. B, her estimate is smaller than x minus y. C, her estimate equals x minus y. D, her estimate equals y minus x. And E, her estimate is 0. So let's say, so if Xiao Li rounded x up by a small amount, then it will be x plus, let's say it's 0.1, and rounded y down by the same amount, so it's y minus 0.1, let's say, and then subtracted her rounded values. That would give x minus y plus 0.2. This is greater than x minus y, so her estimate is larger. The answer is A. Number 7, for a science project, Sammy observed a chipmunk and a squirrel stashing acorns in holes. The chipmunk hid 3 acorns in each of the holes. The squirrel hid 4 acorns in each of its holes, and they each hit the same number of acorns, but the squirrel needed 4 fewer holes. Okay, and so let's say that the squirrel, it needed X holes. And that means that the chipmunk needed X plus 4 holes, right? X plus 4 holes. And so the total number of acorns is the same, right? So 4x, which is from the squirrel, equals 3 times x plus 4, which is from the chipmunk. So 4x equals 3x plus 12, x equals 12, and since the total number of acorns is this, so it's 12 times 4 equals 48. The answer is D. Number 8, what is the sum of all integer solutions to this, right? And so what we can have is 1 is 1 squared and 25 is 5 squared, right? And so x minus 2 squared can be 2 squared or 3 squared or 4 squared, right? And so x minus 2 can be 2, 3, 4, or minus 2, minus 3, and minus 4, right? And so x will be equal to, this is minus 2, right? So we have to do plus 2, so we need 2 for each. And then we can have plus 2, minus 2, plus 3, minus 3, plus 4, minus 4, right? And then we have to add all of these up. And so that would give us, these two would cancel, these two would cancel, these two would cancel, so that would give us 6 of the 2's, which is 12. The answer is B. Number 9, 2 integers have a sum of 26. When 2 or more integers are added to the first 2 integers, then the sum is 41. Finally, when 2 or more integers are added to the sum of the previous 4 integers, the sum is 57. What is the minimum number of odd integers among the 6 integers? Okay, so let's say that the 6 integers in order are A, B, C, D, and E, F. And so that will give the first two integers, the sum will be 26. And the sum of the next 2 integers, since this whole thing is 41, then this should be 15. And the whole sum should be 57. So this is 57. So EF, just this much, that would be 57 minus 41, which is 16. So the minimum number of odd integers, these can be just 2 even. So, and these can be just 2 even, but this needs 1 odd and 1 even, right? And so the minimum number of odd integers is when it's 0, 1, 0, so it's 1. The answer is A. Number 10, how many ordered pairs of positive integers m, n satisfy the equation m over 6 equals 6 over n, right? And so we can cross multiply right away. That gives us mn equals 36, and that is basically the only restriction we have, except that it's positive integers, right? And so what we need is the number of factors of 36, right? And so this 36 equals 2 squared times 3 squared, and so what we need to do is plus 1, and then multiply those. So it's 3 times 3 equals 9. So 36 has 9 factors. So the answer is D. And if you want all of these listed out for you, then it could be then m, n could be 136, 2, 18, 3, 12, 4, 9, 6, 6, 9, 4, 12, 12, 3, 18, 2, and 36, 1. So these are the 9 possibilities. Number 11, a dessert chef prepares the dessert for every day of a week starting with Sunday. The dessert each day is either cake, pie, ice cream, or pudding. The same dessert may not be served 2 days in a row. There must be cake on Friday because of a birthday. How many different dessert menus for the week are possible? Okay, so there's starting with Sunday, right? So Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, right? And there must be cake on Friday. This is a fixed value, right? And so there are 4 possibilities, but then the same dessert must not be served 2 days in a row. So if this is cake, then this must not be cake, and this must not be cake. So there are 3 possibilities and 3 possibilities. If this is fixed, then that will give us this should be 3 possibilities. By the same logic, 3 possibilities, 3 possibilities, and 3 possibilities. So so the total number of possibilities is this times this times this times this times this times this, right? So it's 3 to the 1 2 3 4 5 6 power, 3 to the 6th power, which is 9 to the 3rd power, which is 729. No, 729. So the answer is A. And number 12. Point B is due east of point A, point C is due north of point B, and the distance between points A and C is 10 root 2, and BAC, angle BAC equals 45 degrees. Point D is 20 meters due north of point C. The distance AD is between which 2 integers? So we have point A, and we have point B, which is east of that. Let's make this down a little bit. Point C is due north of point B. So if we connected AB and BC, this will be a right angle because B is right east and C is north. And the distance between points A and C is 10 root 2 and BAC is 45 degrees. Okay, so that gives us some good information because this is 10 root 2. And since this is 45 degrees, this is a 45, 45, 90 triangle. And so by that, we can know that AB is 10 and BC is 10. Point D is 20 meters due north of point C. Okay, so maybe we'll need to bring this down a little bit. Point D is 20 meters due north of point C. So that will be about here, I reckon. And so this will be D, and this will be 20. The distance AD, so from here to here, that is between which 2 integers, right? And so since this is 10, and this is 30, this is 10, and this is 30, and so this will give us square root 10 squared plus 30 squared, which is 10 root 10, right? And so we need to find root 10 is between, or actually 10 root 10, let's just leave that to be, let's just leave that to be root 1000. And we can see that root 1000, this is less than root 1024, and it is greater than root 961, and we know that this equals 31 and this equals 32. So root 1000 is between 31 and 32. The answer is B. Number 13, it takes Clee 60 seconds to walk down an escalator when it is not operating and only 24 seconds to walk down the escalator when it is operating. How many seconds does it take Clee to ride down the operating escalator when he just stands on it? Okay, so let's say that Clee's walking speed is C, and the escalator's speed is S, right? And so it takes Clee 60 seconds when it's not operating, so no S and only C, right? So C, let's say the unit is like meters per second. So so what matters here is that the distance is equal, right? So C times 60, this will be the distance, right? And that will be equal to 24 seconds when it is operating. So walk and operating, right? So that will be C plus S. So C plus S times 24. And we can divide by 12, so that will be 5 and that will be 2. So 5C equals 2C plus 2S. 3C equals 2S. How many seconds does it take Clee to ride down the operating escalator when she just stands on it? So we need the time when it's S, right? And the distance is C plus S times 24, and this is the speed and this is the time, right? And so we need this value when this is just S. And since 3C equals 2S, we can see that C equals, what is it? 2 over 3 S. I'll need a bit more space. 2 over 3 S plus S times 24. And so this is 5 over 3 S times 24, which is S times 5 times 8, which is 40, right? So it's 40. So this is the value that we wanted. The answer is B. Number 14. Two equilateral triangles are contained in a square whose side length is 2√3. The bases of these triangles are the opposite sides of the square, and their intersection is a rhombus. What is the area of the rhombus? Okay, so if we draw this out, then that would become this, right? And so these these are the two equilateral triangles, this one and this one. The drawing's not perfect, but and the side length is 2√3, right? And so this much would be 2√3, and this much would also be 2√3, etc. And the bases are the opposite sides of the square, and their intersection is a rhombus, and then we want this area, right? And this is 2√3 also, and since this is an equilateral triangle, so this is 60 degrees, and so this is also 60 degrees, right? Because this triangle and this triangle are similar, and this are congruent, right? And so this angle is 60 degrees, and we know that this length, that is the height of the equilateral triangle, that is 2√3 times √3/2. This equals 3, right? And so this is 3, but then we have also 3 here too. So that length is 3, but this length is also 3, right? And they overlap. So the overlapping region, this equals 3 plus 3 minus 2√3, because it's this plus this, and then we have to subtract the whole thing. So this equals 6 minus 2√3, and so this much equals 6 minus 2√3. But then we want this part, right? And so that part would be, this much would be 6 minus 2√3/2, which is 3 minus √3. So this is 3 minus √3. And since this is 90 degrees and this is 60 degrees, this is also a 30, 60, 90 triangle, right? And so this is like the height of the right triangle. And so if we want to get the base, then the base would be the height divided by √3, right? And so this is 3 minus √3 divided by √3, and so that would give us √3 minus 1. And so I'm running out of colors here. And so this whole area, so the area of this one triangle, it will be 1/2 times 3 minus √3 times √3 minus 1. And then we want the area of the full rhombus, so we have to do that area multiplied by 4. And so these two cancel, so that becomes 2 multiplied by 2. And if we if we calculate this, this becomes 2 times 3√3 minus 3 plus √3 minus 3. So this will be this. So this equals 2 times 4√3 minus 6 equals 8√3 minus 12. So the answer is D. Number 15. In a round-robin tournament with 6 teams, each team plays one game against each other team, and each game results in one team winning and one team losing. At the end of the tournament, the teams are ranked by the number of games won. What is the maximum number of teams that could be tied for most wins at the end of the tournament? So first, we need to find out the total number of wins, right? And so there are 6 teams, and each team plays one game against each other team. So there is going to be 6 choose 2 games, and this is 6 times 5 over 2. This is 15 games, and this means there are 15 total wins, right? And then the maximum number of feasible teams, that would be 3, 3, 3, 3, 0. No, 3, 3, 3, 3, 3, 0. So that would give 5 teams, right? But then we need to see if this is actually possible. So So let's say, so obviously this team would have lost all the games, so that would be 1-1-1-1-1 for each, and then and then let's say that and then there would be 5 choose 2 equals 10 games, 10 games between these so 10 games between these 5 teams, right? And then let's say that each team won 2, and lost 2, because that so each team won 2 and lost 2 from these 5 teams, and so that would make it possible for 5 teams to get 3, and the leftover person would be 0, and so this is a possible no, and so this is a possible kind of sequence, right? And so what's the maximum number of teams? It's 5. The answer is D. Number 16, 3 circles with radius 2 are mutually tangent. What is the total area of the circles and the region bounded by them as shown in the figure? So what we have to do is, we know that this is filled in, right? And so we have to get these centers and connect them, and that will get us yes, and that will get us an equilateral triangle, right? And so that will be our equilateral triangle. And so radius is 2, so this much is 2, so that means this whole thing is 4, right? And so the triangle, this would be 4 squared times root 3 over 4. This is 4 root 3. And the easy way out would be to just look at the answer choices and just see the one with 4 root 3 and go with that one, because the rest of the area will all be parts of circles, so that will all be in terms of pi. So the answer would be A, but just to check, let's just get these areas. So the leftover area, so the Pac-Man shaped areas, this will be 3 of these multiplied by, this is 5 over 6 of each circle. 5 over 6 of each circle. The radius is 2. So the area of one circle is 2 squared pi, which is 4 pi. So this is these, I'll cancel it to be 2. This is 10 pi. So it's 10 pi plus 4 root 3, and we see that it is the answer. Number 17, Jesse cuts a circular paper disc of radius 12 along 2 radii to form 2 sectors, the smaller having a central angle of 120 degrees. He makes 2 circular cones, using each sector to form the lateral surface of a cone. What is the ratio of the volume of the smaller cone to that of the larger? So let's make a circle, and no, let's make it in black. So that will be our circle, and the radius will be 12 along 2 radii. Okay, so, and this should be 120 degrees because the smaller has a central angle of 120 degrees, right? And then this, and so this part will be 1 cone, and this part will be 1 cone. And so the smaller cone is the cone that uses this part, right? And so for this part, the radius is 12, and so if we have a cone, then we will be able to say that this is 12, right? And then for this, for the radius, we need the circumference, which is basically this length right over here, and that is 1/3 of the whole circumference, right? And so this is 1/3 of the whole circumference, which is 2 pi r, which is 12 times 2 times pi. So this equals 8 pi, right? So the circumference, this is 8 pi, and so the radius equals 4, because 2 pi r is 8 pi, and so r is 4. And we need the volume, so we also need to have the height. And we can see that the height is, by Pythagorean theorem, this is the height, and this is 12, and this is 4, because this is the radius, and this is the and this is this line, right? And so this is root. So h equals root 12 squared minus 4 squared, and this equals 8 root 2, and so the h is 8 root 2. The volume is 1/3 times 4 squared pi, so that's the bottom ratio, that's the bottom area, and times the height, which is 8 root 2. And so now for the big one, for this much, we just have to do the same thing. So this cone will be kind of larger like this, right? And we need the circumference. And so the circumference for this one will be 2/3 of the circumference. And since we have 1/3 of the circumference, we can just multiply that by 2 to get 2/3 of the circumference. This equals 2 times 8 pi. This equals 16 pi. So this much is 16 pi. So the radius would be 8, right? And obviously this much is 12. And same thing, we need to get the height over here. So same thing. This is height, this is 12, and this is 8. And so height equals root 12 squared minus 8 squared, which would equal 4 root 5, right? 4 root 5. And the volume for this would be 1/3 times 8 squared pi times 4 root 5. Right, and so what we need to get is the ratio of the volume of the smaller cone to that of the larger, and so we need to compare these two. And so I'll put them here, and it's that over this here, and obviously these two cancel, pi cancels, and 4 squared and 8 squared they cancel, and this would leave 4 behind, and and 8 and 4 cancel. This will make 2, so these two cancel, it's 2, so it's yeah, these two cancel too. No, actually, let's just multiply root 5. So this would be 5. And so that would give us 2 times 5 under root 2 times root 5. And then we know that that is equal to root 10 over 10. The answer is C. Number 18, suppose that one of every 500 people in a certain population has a particular disease which displays no symptoms. A blood test is available for screening for this disease. For a person who has this disease, the test always turns up positive. For a person who does not have the disease, however, there is a 2% false positive rate. In other words, for such people, 98% of the time, the test will turn out negative, but 2% of the time that test will turn out positive and will incorrectly indicate that the person has the disease. Let P be the probability that a person who is chosen at random from this population and gets a positive test result actually has the disease. Which of the following is closest to P? Okay, so we can see that 1 of every 500 people has the disease. So let's just say that we test 500 people, right? So that's would give us one person who actually has the disease, and we would have 499 people who don't have the disease, right? But then there's a 2% false positive rate, and so don't, but also get a positive. That would be 499, so that would equal 499 times 2%, 0.02, and yes, and this will be similar to 500 times 0.02, because it just said which of the following is closest to P, so we don't need the actual value. And this is 500 times 0.02, so this equals 10, right? And so there are 10 people who got a positive but actually don't, and 1 person who actually does have, so that person would have the positive, right? And so which of the following is closest to P? It's P is the probability that a person is chosen at random gets a positive test result. So positive test result is 10 plus 1 actually has the disease, so that's just 1. It's 1 over 11. The answer is C. Number 19. In rectangle ABCD, AB is 6, AD is 30, and G is the midpoint of AD. Segment AB is extended 2 units beyond B to point E, and F is the intersection of ED and BC. What is the area of BFDG? So let's first draw a diagram of this. And that would be something like this, right? And so AB, this much is 6, AD is 30, this thing is 30, and G is the midpoint, so AG will be 15 and GD will be 15. Segment AB is extended 2 units beyond B to point E. F is the intersection between ED and BC. right here. What is the area of BFDG? So we want this area right over here, and so what we need is just have this rectangle ABCD minus CFD minus ABG, right? And so first of all, what we can notice is this triangle and this triangle, they are similar triangles, right? And so since this is 6, the ratio of the length is 1 to 3, so this will be so if this is A, then FC will be 3A, right? But then we know that the whole thing is 30, so if so A plus 3A equals 30, A equals 15 over 2, right? And so BF will be 15 over 2, and FC will be 15 over 2 times 3, so this is 45 over 2, right? And then BFDG, that's what we want. And so yeah, first let's write up let's just write up how to get BFDG. It's ABCD, which is 6 times 30, which is 180, minus CFD minus BAG, right? And then CFD is 45 over 2 times 6 times 1 over 2. This equals 45 times 3 divided by 2. This equals 135 over 2, right? And we know what BAG is. BAG is 1/2 times 6 times 15. This is 3 times 15, this is 45. And what is the area of BFDG? This is 180 minus this much, which is 135 over 2, and minus 45. This equals 135 minus 135 over 2, which equals 135 over 2. So the answer is C. Number 20, Bernardo and Sylvia play the following game. An integer between 0 and 999 inclusive is selected and given to Bernardo. Whenever Bernardo receives a number, he doubles it and passes the result to Sylvia. Whenever Sylvia receives a number, she adds 50 to it and passes the results to Bernardo. The winner is the last person who produces a number less than 1000. Let n be the smallest initial number that results in a win for Bernardo. What is the sum of the digits of n? Okay, so let's just have Bernardo and Sylvia, and if Bernardo gets A, right, if he has A, then he doubles it and passes the result to Sylvia, so Sylvia gets 2A. And oh no, let's just start with if Bernardo gets A, then he will do 2A to it, and then Sylvia would get it, and she will do 2A plus 50 to it, and Bernardo will get it, and he will do double it, right? So that's 4A plus 100, and Sylvia will do 4A plus 150. Bernardo will do 8A plus 300. Sylvia will do 16A plus 700, and Sylvia will do 8A plus 350, and Bernardo will do 16A plus 700, and Sylvia will do 16A plus 750, and Bernardo will do 32A plus 1500. So obviously this would be where Bernardo loses. And so if Sylvia were to lose, so if Bernardo would win, then Sylvia has to lose at here or less, right? And so 16A plus 750, 16A plus 750, this has to be more. Yes, so 16A plus 750 has to be more than 1000, right? But then we also have to keep in mind the fact that 16A plus 700 also has to be less than 1000, right? So if we move this a little bit, then that will give us 16A plus 700 is like this, right? And so 16A will be greater than 1000 minus 750, which is 250, and less than 300. So A would equal Yeah, so a is equal to n here, right? And so let's just make a n now. What is the sum of the digits of n? So n would be less than 300 over 16, more than 250 over 16, and so n has to be the smallest. 18.7, so that would be 18 and 3 over 4, and 250 over 16, that would be 15 and 8 over 5, no, 15 and 5 over 8, right? And so since n is between these two, then the smallest n would be 16, right? And so the answer would be 7, which is A. Number 21. 4 distinct points are arranged on a plane so that the segments connecting them have lengths A, 2A, and B. What is the ratio of B to A? Okay, so first thing we notice is that there's multiple A's and there's a 2A in here somewhere. And so we have 4 points and there's one 2A in it, so that would make it seem like there's three of the points with distance A, and that would give the total distance 2A, right? And we need 2 more A's and 1 more B, and instinctively kind of this would be the right answer because this would be A, this would be A, and that would just give us D. No, that would just give us B because it's very convenient, right? And it all matches up, so we can say that this is our answer that we want. And since this since this would be an equilateral triangle, this would be that would be 60 degrees, and since this is 60 degrees, this is 120 degrees, and since this is an isosceles triangle, this is 30 degrees, and so this is 30 degrees, right? And so what is the ratio of B to A? So then since this is a 30, 60, 90 triangle, this is 2 and this is A, so this is root 3A. So B equals root 3A. What is the ratio of B to A? Root 3A over A, that is root 3. The answer is A. Number 22. Let A1, A2, all the way to A10 be a list of the first 10 positive integers such that for each I like this, either AI plus 1 or AI minus 1 or both appear somewhere before AI in the list. How many such lists are there? Okay, so first of all, let's try to think of a list which would meet these conditions, right? Right? And so the simplest that we can think of is just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that works because for every number, because for every number AI minus 1, it is in front of AI when I is greater than or equal to 2, right? And so this is the only and it turns out that this is the only way when the first number is 1, right? And this is the only way to do this when the first number is 1, because just think about it. If any number other than 2 were to come to the right next point, because then let's say like 4 came, then would 4 being here, would it meet these conditions? So 3 or 5, they don't appear before 4, right? And so 4 cannot do it, and that's the same for all the rest of the things except 2, because 1 is 2 minus 1, so that appears before it in the list. And by the same reasoning, 3 must be here, 4 must be here, all the way to 10. And so this is the only way when the first number is 1. And next is if the first number is 2, right? Then the first number is 2, right? And we know that all the rest of the numbers except for 1, so 3, 4, 5, 6, 7, 8, 9, they must be in this order: 3, 4, 5, 6, 7, 8, 9, because regardless of where 1 is, since 2 must be here after 2, so right after 2, so the right next non-1 number after 2 must be 3, and same thing for 4, and same thing for 5, because of the same logic that we used here. And so 3, 4, 5, 6, 7, 8, 9, that must be in this order, and 1 can go anywhere in here. So 1, 1, 1, 1, 1, 1, 1, 1, that's all possible. So that means after leaving 2 in the head spot, we have 9 spaces left, right? And so we can have 9 choose 1 ways to put 1, right? And then say let's put 1 here. Then the rest, which is 3, 4, 5, 6, 7, 8, 9, 10, that would just all fall in line in order like this, like 3, 4, 5, 6, 7, 8, 9, 10, right? And so this gives us 9 choose 1 ways, and very similar thing for the first one equaling 3. And so if the first one is 3, there are also 9 slots left. And so now we are thinking about where 2 and 1 goes, right? And so first of all, some people think that 1 and 2 and 2 and 1, they are both possible, but this is not true, because let's say it was 3 and something and 1 and 2, then would 1 meet these conditions? The only number that would meet conditions for 1, that would be 2, and 2 is not before 1, right? And so it must be 2 and 1, and the rest of the numbers, which is 4, 5, 6, 7, 8, 9, 10, they will just all fall in the remaining categories, in the remaining slots, right? And so what we need is 9 choose 2 ways to put 2 and 1, because we only need to choose 2 slots, and then 2 and 1 will go into them, and it doesn't matter what order they're in. No, right? Because the first will always be 2 and the next will always be 1. And very similar thing for the first number being 4, and so if it's 4, then there's also 9 slots left, and then this time we will only have to do 9 choose 3, because this has to be in descending order, 3, 2, 1, and then the rest will be in increasing order, 5, 6, 7, 8, 9, 10, right? So it's 9 choose 3, and all the way to 9 choose 10. No, sorry. And all the way to 9 choose 9 ways when 10 is here. Then all of these would have to be in decreasing order, so that would be 10, 9, 8, 7, 6, all the way to 1. And so what we have to do is add up everything, and the first one is 1, and 1 equals 9 choose 0, right? And if we add up 9 choose 1 all the way to 9 choose 0, that gives us 2 to the 9th power. This is 512, so the answer is B. Problem number 23. A solid tetrahedron is sliced off a wooden unit cube by a plane passing through 2 non-adjacent vertices on one face and 1 vertex on the opposite face not adjacent to either of the first 2 vertices. The tetrahedron is discarded and the remaining portion of the cube is placed on a table with the cut surface face down. List the height of this object. And so to kind of visualize this, let me draw a diagram of it. So this would be that, and this would be the black parts, this would be the unit cube, and so this would be 1, 1, 1 all around, right? And this and this triangle is the plane that was cut, and so as I said, it passed through 2 non-adjacent vertices and 1 vertex on the opposite face not adjacent to either of the first 2 vertices, so it's this one, right? And then we want the height of the object, which is this length, right, that I've circled there. And so what we can do is use the volume of this side, so use the volume of the triangle-based pyramid to get that height, right? And we can subtract that from root 3, and that will be our answer. And so first, we know that this is 1, this is 1, this is 1, right? And we also know that this is root 2, and root 2, right? And so first, let's try to take the volume by having this as the base and this as the height, right? So that will be 1/3 times the base, which is 1 times 1 times 1/2, times the height. So this is 1/6. But then this is equal to, when we calculate it by having the base being this equilateral triangle and the height being this much, right? And so let's say this is h. This is equal to 1/3 times this, which is root 3 over 4 times root 2 squared times h. So this equals 1 over 3 times root 3 over 2 times h. And so this equals 1 over 6. These two cancel, and so root 3 times h equals 1. H equals 1 over root 3. And we need the height of this object, which is root 3 minus h, right? So root 3 minus h equals root 3 minus, this is equal to root 3 over 3. So this is 2 root 3 over 3. So the answer is D. Number 24. Amy, Beth, and Joe listen to 4 different songs and discuss which ones they like. No song is liked by all 3. Furthermore, for each of the 3 pairs of the girls, there is at least one song liked by those girls but disliked by the third. In how many different ways is this possible? Okay, so there are 4 different songs. And we have Amy, Beth, and Joe. Right? And there's at least one song liked by 2 girls but disliked by the third. So at least one has Amy and Beth like it, Beth and Joe like it, and Amy and Joe like it. And the mystery is who likes the 4th song, right? And so first, the people who likes the 4th song could be nobody could like the 4th song, or it could be just Amy or just Beth or just Joe. And so that would give us one section. And the second section is Amy and Beth could like this one too. Beth and Joe could like this one too, and Amy and Joe could like this one too. And the reason this is separated is because the number of cases for this, for the 4th one being this, and the number of cases for the 4th one being this is different. Because this one there's an overlap, right? And so for this one, let's put it in red. There are 4 different preferences and 4 different songs. So there are 4 factorial. So there are 4 factorial ways to do it, and there are 4 choices as to which one could be the 4th song, right? So times 4. This equals 24 times 4, which equals 96. And this one where it could be A, B, B, J, and AJ, or AJ, and so that means there will be 2 of the same thing and the others will be different, right? So this is 4 choose 2. So this is 4 choose 2, because we are choosing which ones will the 2 same people like, and we multiply that by 2 because we are choosing who will like the other, who will like the first of the other left songs. And since we also have 3 choices, we can multiply this by 3. This is 4C2, which is 6 times 2 times 3. This is 36. And so if we add them, this will give us 132. So the answer is B. Our last problem. Number 25. A bug travels from A to B along the segments in the hexagonal lattice pictured below. The segments marked with an arrow can be traveled only in the direction of the arrow, and the bug never travels the same segment more than once. How many different paths are there? Okay, so first, let's try to divide these paths, right? And so first it could be divided right over here, and it could also be divided right over here, right? And that is to put space for using this, right? And first we start from A, and to go to each of these 4 points, we need to look at the number of possible ways we can get to this point, right? And so for this point, it's 1 and 2 and 3 and 4 and 5. Again, 1, 2, again 1, 2, 3, 4, and then using this one, the last one, will be 5. So there are 5 ways to do that, right? And for here, and since this is the same as the first one, but then just this is just the direction is different to here, this would also be 5. And since these are a mirror image of these two, these would also be 5s, right? And the next is this part, and from here let's try to get to this point first, right? Starting from here. So here this would be 1, and then using this would be 2, using this would be 3, using this would be 3, and using this would be 4, and using this would be 4, right? And now we have to, yes, and that's basically all. So we have 4. And same thing for here, we also have 4. That's this is all coming from this one point, right? And if we're starting from here, that would give us 1, 2, 3, and 4, just like the previous one, so plus 4. And let's try to go under now, right? So let's try to start here, right? As we're starting from here, the same 1, 2, 3, 4, that's there, but also this time we can use this to cross over to here, right? So plus 4, and then we can use this one, so that would be using one of these two and then using one of those two, right? So it's using this and then this, or using this and then this, or using this and then this, or then this and then this, right? So that would be 4, right? And same for here, that would also be, and same for over here, that would also be 8, right? And so the whole thing here is 4 plus 4 plus 8 plus 8, which is 12 times 12, which is 24, right? So that's 24. And then for the second one, same reasoning as here. It's all the same as this one, except except that the direction is one lower, and so it's just the same. So it's 24, and by the same reasoning from here to here, it's a mirror image, so it's 24 and 24. Lastly, let's write these 24s on the left side. 24, 24, 24, and 24, and 24. Lastly, going from 1 to B, so let's count that. There could be 1, or 2, or 3, or 4, or we could use the reverse thing and go like this, so that would be 5. And there are no other ways to go from this to B. 5, right? But then if you think about it, the number of possible ways from going to B from all of these would actually just be the same, right? And so all of these would just be 5, right? So it could be 5, 5, 5, 5, 5. So 5 from here, 5 from here, 5 from here, 5 from here, right? And so this would be equal to 20. And then so what we need to go is, since we can go by each point just once, and all of the possible ways at each checkpoint is the same, we can just multiply one of these, right? So it's 5 from here times 24 times here times 20 which is from here, right? So this would be 24 times 100. This is 2400. So the answer is E. That was it for problem number 25, and thank you for watching.